moderator for today's session. Your presenter today is Mr. Roger Harrison, Director of Training, who conducts our monthly safeguarding seminars here at our headquarters training center, and is a frequent speaker at the Precision Metal Forming Association, Ohio Safety Council, FabTech, numerous other safety councils, and other venues. You have arrived in listen-only mode so that the presenter can speak clearly without background noise. At the end of the webinar, we will have about 5 minutes for Q&A. Also, please do stay until the end of the webinar so that you can cast your vote in our poll to help us improve the quality of our webinars for the future. Also, this webinar is being recorded and you can watch this on our YouTube channel within 24 hours. And finally, the webinar slides can be downloaded directly from your webinar control panel in PDF format. Also, for those of you who attended our Robot and Cobot webinar last month, we did kind of run out of time. Wanted to let you know that we re-recorded the entire webinar, which turned out to be about 55 minutes, and that is available for your viewing on our YouTube channel as well. Okay, so today's topic is very broad, and all we can really do in a webinar is skim the surface. So if you see a YouTube or blog icon in the upper right-hand corner of a slide, that means that we have published free content that delves into the slide topic in much more detail. So for example, today you will see a slide on die safety blocks with a blog icon. If you would like to learn more about die safety blocks, simply go to our website and read our full die safety block blog. Similarly, today you'll see a few slides on AOPD and Lazer Safe with a YouTube icon. If you would like to learn more about Lazer Safe, go to our YouTube channel and watch our webinar entitled AOPD versus Light Curtains. So just a bit about Rockford Systems before we jump into our topic. Rockford Systems provides turnkey safeguarding solutions for organizations working with industrial machinery. We are a private company founded in 1971 and located in Rockford, Illinois, just outside of Chicago. Our services range from training and to education to risk and machine safeguarding assessments, installations, and post-sale support. Please visit rockfordsystems.com to learn more about us and follow us on social media. So both press brakes and power presses can be very dangerous and unforgiving pieces of machinery. They move really fast, they move in only one direction, and they have to complete the stroke. The average mechanical press is capable of producing 150% of rated tonnage at dead bottom of stroke. The Department of Labor says that there are over 350 amputations suffered each year in the U.S. So please keep in mind that not many accidents are reported to OSHA because of potential fines, so we would expect the actual number to be much higher. So first we're going to start off talking about press brakes, and then we'll switch into power presses. And I'd like to turn it over to Roger.
Good morning, everyone. Let's start talking about press brake hazards. You're looking at a typical hydraulic press brake with a relatively long part, maybe almost 4 feet in length and maybe a foot wide. So the first hazard is the dies that close at the point of operation, which are accessible from both the front, the sides, and even the back, as a matter of fact. Next danger would be the vertical movement of the piece part during the bend. The operator were not aware that this part were bending up. It could cause serious injury to his chin or face as it bends up. And 3, you've got the hazardous movement of an automated back gauge system, which is usually in the back, but could be around the front. There are front gauges as well. So you got material movement and you have machine movement. Additional hazards might be that older press brakes need new controls before you can install things like light curtains or even two-hand controls. The original equipment manufacturer, the press brake, usually considers that the point of operation hazards are the responsibility of the end user or the employer. And OSHA goes along with that as well. So they oftentimes do not provide safeguarding. And fabricators don't oftentimes have people that are real knowledgeable on safeguarding with their background and experience. Remember that both presses and press brakes are very operator intensive, so training is required, as is communication between two operators if you have more than one. Risk assessments are also very important and are seldom completed on this type of machine. So risk assessments, which came around at the turn of the century, about 1999 is the first one that I saw, considers hazard exposure. You got the severity, the frequency, and the probability of injury, as outlined by the ANSI B-11 and 2015, which is risk assessment for industrial machines. So risk assessment is your best and most comprehensive approach to establish a safe and effective safety system. That's what you need to start with. A press brake used in a fab shop poses many serious risks, point of operation, and may result in amputation, crushing, or even death. Forming a risk assessment. You can do this yourself. You can hire somebody outside to do this, but you do need a risk assessment. That's before commissioning new machinery, after upgrading machinery, or changing the area of work, or after any accident or serious injury. So OSHA considers a press brake a 212 machine, meaning it's the employer's responsibility to furnish a safe and healthful workplace free from recognized hazards causing death or serious physical injury. American National Standards Institute has a B-11 series of machines on metalworking, one of which is B-11-3, which was last updated in 2012, which, by the way, now incorporates or folds in information from the European standard EN 12622. So that is up to date in every respect. Updated controls and light curtains, what you're looking at on this 1970s version mechanical press brake. Notice the operator can still operate this with a foot treadle, which sometimes they prefer to a foot switch because they can slip the clutch and control the speed of the bend. So you can see the die that you're using here, a part that's about a foot wide. The yellow box above the operator's head is part of the light curtain system, and you can see the yellow light curtains on either end of the machine that form an invisible vertical sensing field that detects if the operator is reaching in too far. The photograph on the right shows some of the control components that are part of this updated system, both the electrical and the air and pressure switches and FRLs and disconnects you can padlock in the on position, magnetic motor starters, etc. So here's a press brake using a light curtain, also a 1970s machine with updated controls and light curtains. And it's also got a guard at the top right corner here that covers rotating components. So on this machine, we've got a two-hand control, we've got a foot switch, we have a vertical light curtain. The only concern might be somebody being able to stand in between the light curtain and the machine, maybe drag the foot switch in there along with them, and operate the machine from the wrong side of the light curtain. So if the part moves up through the sensing field, the bending motion may stop before the cycle's finished. To avoid that problem, there's two common things you can do. You can mute or turn off the light curtain during the non-hazardous portion of the cycle, that is the upstroke when the part's bending up, so that there's no interference between the part movement and the cycle. That's most common, just mute the light curtain. Or if your light curtain happens to be equipped with a float or floating blank feature, then you can set it to allow the piece part to move up through the sensing field, but not allow your hand in there. So that would protect you on both the downstroke as well as the upstroke if you use a floating blank, providing your light curtain is equipped with that feature. Now in the old mechanicals, sometimes people resort to a restraint device, which is nothing more than a dog leash type of thing that allows you to support the part, but not to reach the die. So it's got to be adjusted in such a way that your fingers can never reach the point of operation hazard. And again, that's the die we're referring to. can also be set up for more than one person. Now, oddly enough, as simple as this is, people don't like them usually because they don't allow enough freedom of movement. You're actually tied to the machine. Although this device is legal in the OSHA regulations, and it's still recognized in the ANSI B-11 standard as a viable safeguarding method, especially on the old mechanicals. So people have an old machine, they say, you know, we got to keep this thing for another 3 or 4 months before we get its replacement. How do we safeguard it? Well, that's the least expensive thing that's recognized by both ANSI and OSHA as a safeguarding method. Hand feeding tools, you use these, especially when using restraint devices we talked about, should be made of a soft material like aluminum or even pot metal to prevent shattering. So if you close the machine on these, they'll squash, not shatter. You never want to use a hardened steel tool around a press or press brake die. Sufficient length to allow you to feed the part, but not put your fingers in between the point of operation as you feed the piece part. Ergonomic design would ideally be the handshake position if you're using one of these. But remember, somebody could put a hand feeding tool down and use their hand instead, which is the downside of this. Most of the press brakes manufactured since the mid-80s are hydraulic. You can see hydraulic cylinders, like for instance, here's a hydraulic cylinder on this one, another one on the other side. On the machine on the right, they're around the back. They're hydraulically driven. The one on the left, the top half goes up and down, so it's referred to as a down-acting hydraulic press brake. The one on the right, the bottom half goes up and down. So that's referred to as a beam, B-E-A-M type press brake, both of which could use a light curtain, which is the case for both of them here. They both have an infrared light curtain on them as a primary safeguarding means. Now, the problem with the light curtain on these hydraulic press brakes is you really can't hold the piece part up close with your hands, because with a light curtain you have to blank out so many cells or channels to accommodate your hands and maybe wrists, for instance, that the light curtain is ineffective. So we do have a vertical light curtain on here, but we have also supplemented that with an active optoelectronic protective device, or a laser, offered by about 4 or 5 different manufacturers. It's been around since 2001, because lasers allow people to hand hold a small part up close. That's the main reason for using a laser versus a light curtain. However, there are some dies that won't allow you to use a laser, and that's why the light curtain is here as a backup. It's not that regulations or safety standards require both. That's the reason for both. You look over on the far right, you've got a 2-hand control on a movable floor stand, and then you've got a foot switch down below. Those are sometimes used in conjunction with each other for what they call 2-hand down, foot through sequence bending operation, which uses the idea of a 1/4 inch opening as a safeguarding method. Then there are hinged corner guards to keep other people out, which swing out of the way and allow you to load the tooling from the end of the ram, which is required in many cases. What you cannot see here is there's a guard across the back of this machine as well, because you do need something, whether it's a guard or an awareness barrier, as we'll discuss later. Remember, these AOPD laser devices are designed only for hydraulic and also servo drive press brakes, not for mechanicals. Don't even think about these for mechanicals, because mechanical press brakes don't stop fast enough to justify a safeguarding device that's mounted with 0 safety distance, which is the case with a laser. So here, this is the 2 reasons that people go to lasers instead of light curtains. On the top, hand holding small parts up close. On the bottom, bending parts that already have a tall side leg on them, which if you're using a light curtain would require excessive blanking. So that's the 2 primary reasons right there. Keeping in mind that a laser device is probably 4 times the cost of a good category 4 light curtain. So if you compare the 2, the main advantage is that lasers allow you to reach closer than light curtains do. Sometimes they're referred to as camera-based laser systems, because some are and some are not. but they are categorized as an AOPD. So they're primarily for box bending or bending flanges or applications where light curtains would require excessive blanking. That's where you'd use them. This is the Lazer Safe Sentinel Plus that our company happens to handle. You can see some of the advantages and the features over on the right-hand side. Various modes of operation, and the LEDs are visual or graphic. You can monitor the speed. They have quick adjust brackets because it takes about 15 to 20 minutes to change over from one job to another. So obviously, these are best for medium or longer range jobs as opposed to just onesie-twosie stuff. Then there's automatic tool alignment as well. So can press brakes be automated? So you're using a robot to feed the part? Yes, it can. Here's a good example. This has been going on since the mid-1980s. There's a robot that would feed the part. There is an entry area in the perimeter guard for light curtains. Notice it here. There's your transmitter, and then over here is a receiver. But the problem is there's too much space underneath the light curtain. People can sneak underneath them if they want to go in and try to retrieve something without shutting everything down, and that's where some fatalities have been involved. So you got to watch the fence height to make sure there's no more than 6 inches opening at the bottom. And that's as far as the distance from the floor to the top rail, that's anywhere between 72 and 84 inches as a best practice for the fence height. They do not specify what the height of the light curtain has to be. On the back, you need something. At very least, that would be an awareness barrier, like you're looking at the double rails on the left side, plus there's a grab bar e-stop cable. Notice that they've come out from the frame, side of the frame of the machine here, with a bracket that then connects to this one that goes across and back on the other side to keep you far enough away from the two hazards you find on the back, that being the back gauge and the potential for reaching the dies, which are way up here. On the right side, you find a guard. Well, in most cases, OSHA would like to see everything guarded, and there are some states that won't recognize an awareness barrier on the back of a press brake. They want it physically guarded. One of those is in Wisconsin, or at least portions of Wisconsin, that are looking at guards as the best practice, and that's what they want to see. Moving on to power presses. And as Carrie said, keep in mind, we're just touching the very tip of this stuff. Between presses and press brakes, you got 10 hours worth of material that we spend in a 2-day class to really explain this fully. We're doing it in less than 30 minutes. So mechanical power press in the continuous mode of operation with coil stock paying off here on the right-hand side, unwinding. Then it goes through a straightener to take out the curvature or the coil set. Then it goes to a feed, which then feeds a certain length or progression of feed length into the dies to feed the press, to make the part. The press itself has a point of operation guard that slides up and down on a vertical rail, which is electrically interlocked, so it has to be closed where you can start the machine up. What do we have to keep people out of the auxiliary equipment? That would be awareness barrier chains in this case that go from one component to another, which, by the way, are considered better than just a yellow line on the floor, because with the yellow line, you could step over it intentionally or unintentionally. With the chain, you have to make a conscious effort with it and a contact with the chain to get past it. So no, it's not as good as a guard, but very few companies physically guard in a coil-fed press. They have chains. And the chains should have danger warning signs to specify what the hazard is in getting beyond the chain. You know, not just verbiage, but, you know, pictogram type drawings if at all possible. So if you're running continuous and you have a point of operation guard, open back inclinable mechanical press, meaning it's leaned back on an angle so gravity can help drop the parts out the back. This one has a guard that meets OSHA's basic requirement of not being able to reach over, under, through, or around the guard. OTA, an acronym you can remember there. This is an old hairpin type of guard structure, but it's still used in some plants. Over, under, through, and around. So the basic requirements here from OSHA. OTA, as we just discussed. Table 0-10, which I'm coming back to. You don't want to create new pinch points by the way you design or install the safeguarding. Want good visibility into the point of operation. Fastener is not readily removable, which means you need a tool to get in there, not just a wing nut or something you can get into by hand. So those 5 items are in both OSHA's regulations and ANSI's B-11 standard. The ANSI standard also offers a couple of additional things on the bottom that are not in OSHA. Material strong enough to protect people and no sharp edges that could injure people. Common sense stuff, but it just happens that OSHA doesn't list it. So if you're trying to design a guard or buy a guard, keep these things in mind. That's OSHA's guard opening scale to control guard openings and guard distances. This is based on a woman's size 6 glove with average finger length. They don't want a small hand to be able to reach far enough to the guard opening to get to the point of operation hazard is the idea. Over on the far right, the yellow box shows you the largest allowable OSHA guard opening, which as you can see is a 6-inch opening 31.5 inches away, which on most people would be armpit to fingertip, if you think about it. They send a size 6 woman's glove. OSHA sometimes refers to this as a gotcha stick. This actually came out in the late 1940s when they were updating an ANSI B-11 standard for presses to try and control guard openings and distances. Then OSHA adopted it later in their regulation 1910-217. The mid-90s, they came out with an alternate scale for even smaller hands based on a woman's size 4 glove, which we refer to as the ANSI guard opening scale, whereas the one on the top is referred to as the OSHA guard opening scale. Two-hand control is considered a safer way to initiate the cycle of a machine than a foot switch. Any accident study will show you that. So you have to protect the buttons from unintended operation to use them as an actuating means. Then, if you want to use the two-hand control as a safeguarding device because you're single cycling the machine, feeding one part at a time, there's some extra rules. Like, for instance, protecting the buttons from unintended operation. Anti-repeat, meaning you have to push and release both buttons for every single cycle that you get. Half-second time limit between pressing button A and button B. Holding time. You have to hold on to the buttons, contact or pressure, whatever is required during the hazardous portion of the cycle. In other words, while the dies are closing. Interrupted stroke protection. So if you should release one of the 2 buttons during the downstroke, the machine stops. But before you can reinitiate the machine, you have to also release the other button and then reinitiate, push them both again to get it to pick up where it left off. And then anchoring it as safety distance, which we're going to talk more about later. So that's the basic rules to use a two-hand control as a safeguarding device. So light curtain presence sensing safeguarding devices has been around since the mid-1950s. They can be applied to most any machine that you can quick stop mid-cycle, generally in less than a second, without tearing up the machine or creating another safety hazard by doing that. So lots of different machines are applied to, 20-some different manufacturers worldwide that have made these since the mid-50s. That was the earliest one. So this machine has a combination of light curtains. You can see the light bars here, two-hand control, and side guards around the sides, back, top, and bottom to keep other people out of there. Those 3 things are a common combination for a number of different machines. Now, the light curtain features will vary, and you got to be very careful to tell whoever you're buying the light curtains from exactly how you're going to be using it. So infrared light curtains. On this machine, you can see the infrared light beams, which are obviously invisible, that are drawn in here so you can see where they are. So this is a vertical mount of infrared light beams with light emitting diode for transmitter and receiver. These are not laser beams, at least not yet. I've heard they're working on some of those. So it prevents or stops machine movement when the object enters the sensing field. The operator's got to be outside the protective area for the hazardous part of the cycle, that's the downstroke, and the safety distance has to be established. Sometimes people call it a setback distance for the light curtain, to make sure it's far enough away so if somebody were to reach through it flat-handed, like karate chopping, they couldn't get into the dies too soon. They couldn't beat the machine, in other words. That's why a safety distance is required. So you need some sort of a stop time measurement device, whether it's built into the controls or portable, to determine that stopping time, like this. So this can be used for both presses and press brakes, and it can be adapted to use on other machines that have rotating cylinders or rolls, as a matter of fact. So if you have a lot of machines with light curtains or two-hand controls, you may want to consider purchasing your own device, because the alternative is to have a consultant come in that does this on a regular basis and check your machines for stopping time, which is generally something you need to do on a quarterly basis, 4 times a year. So you have to make the decision, do the math, figure out whether it's better off to buy your own or have it done. And that's a service that we can provide, by the way. Function testing your point of operation safeguarding before you start every operating shift. Is that an OSHA requirement? No. It's an ANSI best practice. It may come into OSHA eventually, but right now it's a best practice thing. Now, if you can read that function test checklist for two-hand control at the top line, this is a generic function test checklist. What you really need, if you're dealing with light curtains, is a make model specific function test procedure. One size does not fit all. So with light curtains, you may have to do some homework by going onto the website of the light curtain manufacturer to find out different things like the minimum object sensitivity, beam spacing, and just what the procedures are, along with a couple of test rods, usually a fat one and a skinny one, goes along with function test procedures. Other safeguarding, like, say, two-hand control or point of operation guards with interlocks, it is okay in some cases to use a generic function test procedure. For those of you with mechanical power presses, remember that OSHA requires a safety block anytime you're adjusting or repairing dies while they're in the press. The electrical interlock system is actually a requirement taken from ANSI B-11 because there are safety blocks in the past that haven't had the interlock, where somebody has left the safety block in the point of operation, forgot it's there, cycled a great big press on it, and it came shooting out of it like a missile and killed somebody. So where fatalities are involved, oftentimes OSHA will pick up ANSI B-11 standards to fill in the gaps of their own rather antiquated regulation. Electrical interlock safety blocks. You notice the short chain on that yellow plug? That's very important. You don't want somebody leaving the power plugged in while the block's in the dies. A short chain is required. Ideally, you put the block in the die, although it is possible to put it between the bolster plate and the ram if you don't have room in the dies. The important thing down here at the bottom is you must wait for the flywheel to stop before you place the block in the point of operation. And people are anxious today, they're pushed by productivity, and sometimes they don't want to do that. So sometimes you have to put a flywheel brake on the machine to slow it down quicker if that's an issue. As far as identifying your dies with mechanical power presses, there's 1, 2, 3 areas there. First one, minimum tonnage, minimum stroke. You have a choice. You can stamp that information into the die shoe, or you can have records readily available to the die setter. Second one, you have to stamp the upper die weight. So if you're using this in a press that has a counterweight, you know how much pressure to put in a counterweight system, how much PSI. Thirdly, you got to stamp the complete die weight so you know what sort of die handling equipment you need to pick this up. And then the shut height based on stroke down adjustment up. That's in the ANSI standard, but it's not actually a mandatory thing in OSHA. This is an OSHA requirement. Periodic and regular inspection of your mechanical power presses, which includes that stop time test, by the way, I mentioned, which is usually, in most states, quarterly. That's how they define periodic and regular inspection. There are a few states that define this as monthly. What do you have to inspect in the middle there? All press parts, auxiliary equipment like payoff reels, straighteners, feeds, scrap choppers, whatever, and safeguards. That's what you have to inspect. Well, you have to document down below the date, signature, press number, and then there was a change in the bottom right. Supplier's got to develop, maintain a certification record of maintenance and repairs, which used to be in the weekly inspection paragraph. 5 years ago, they moved it to this paragraph. Let's see. This is in our catalogs and our materials that's on our website. It's a 5-page press inspection checklist. 1 through 13 is press parts. 14 is point of operation safeguarding, and you have to fill in the auxiliary equipment. Next page shows you the same stuff in writing, and there's a 3rd, 4th, and 5th page that show you line drawings of where that stuff is on the press. This is sometimes confused with the laser device we talked about on press brakes. No, totally different thing. This is an area scanning resonance sensing device that you set down around ankle or shin height, sweeps the area in an area that you have programmed with your laptop to make sure nobody gets into a hazard area, and if they do, stops the machine. So there's a warning zone, that's the light shading, and there's a fault zone, that's the dark shading. And you can reset it if your parameters change. Now this is a type 3 device, type or category 3 device down here, which most of the better light curtains are category 4. This cannot be a 4 because it does not have a separate transmitter and receiver. Or is its safety integrity level, which is another European designation. This is a SIL 2, there's a better light curtains are a SIL 3.
Okay, thank you so much, Roger. We do have a few basic safety rules that can and have saved people's lives. We actually don't have time to go through them, but you can read through them if you download the handout. Okay, so let's move into questions and answers. If anybody has a question, feel free to type it into the chat box. Alternatively, you can email your question to roger.harrison@rockfordsystems.com, and we will do our best to get right back to you. So I'm going to just look for some questions here. We have one question, which is, do you have a YouTube channel? Yes, we do have a YouTube channel. This is our social media icon set here. We have Facebook, Twitter, LinkedIn, and YouTube. We have Blogger and Google+. So if you go to YouTube, just type in Rockford Systems to find our channel, and you should be able to find all kinds of good stuff there. Okay, we have a question from Josh. You mentioned never using a hardened steel tool around a press brake. Why? Are the punches dies hardened? What is the hazard of a die punch breaking off and flying off, injuring the operator if present with too much tonnage?
Well, yes, the dies are hardened steel. If you're using a hardened steel hand tool like an electrician's pliers or long nose pliers, you close the press or press brake die on these, something's going to shatter. And when it shatters, it explodes. It's either going to be the die or the hand tool. So always use a soft metal tool if you're feeding stuff into the dies. Okay.
We have a couple questions about where to download our handouts. So your GoToWebinar control panel should have a section called Handouts. If you click the arrow to open the Handouts section, you should be able to find the PDF of today's presentation. Okay. So we have a question from Victor. I may have missed it, but do you do anything about iron workers?
Iron workers generally have guards or covers or flaps that come down over the multiple points of operation hazard you have on that machine that are supplied by the machine manufacturer. But on the old ones, they may not have that. You may have to make your own.
Okay. We have a question from Corey. What requirements are there for a leaf press that does not do large run orders?
I'm sorry, I don't know what you mean by a leaf press. You may have to email me a photograph of that, and I can equate it with something else or another standard regulation.
Okay. We have a question from Genevieve. How do you perform a stop time with a built-in process? Do you just break the light curtain and record the time?
No, actually, it's a position on your solid state control where you key over to program and then you scroll down to stop time measurement. And then, as you said, you press the controls and it'll give you an automatic reading of the stop time, if that's what you have.
Okay, we have a question from James on a shear, actually. Does the awareness guard serve to sufficiently guard the back of a shear?
Yes, as far as it would guard a press brake. I mean, it's something back there that you'd have to make a conscious effort to get into. So awareness barriers, usually three-sided on the back of a shear, perform the same thing as a three-sided awareness barrier on the back of a press brake, assuming you're in an area of OSHA that accepts awareness barriers versus guards.
Okay, so unfortunately we are out of time, but please do cast your vote in our poll and give us some feedback on today's webinar. While we're casting our vote in the poll, I just want to remind everybody that we do have a lot of information that goes into a deep dive on a lot of these topics today. So please do check out our YouTube channel, look at our webinars and our videos. Also go to our website under resources, and you can find our machine safety blog that has, I think, at least 40 different blog posts on various safeguarding topics. Okay. All right, so thank you so much. We also wanted to invite you to, if you'd like to learn a lot more about this information and more safeguarding topics, we'd like to invite you to our 2.5-day machine safeguarding seminar, which is conducted here at our headquarters training facility. Alternatively, we can come to your location. We are also offering now OSHA 1030 General Industry and Hazard Communications classes. We invite you to get your OSHA training. Visit rockfordsystems.com under training to register for any of these classes. Our next webinar will be in April on safety hierarchy. Again, a mini webinar, only 30 minutes. And then at the end of May, Roger will host a Machine Safeguarding 101 webinar, which will be a full 60 minutes. So you can sign up for these webinars also on our website. Okay, thank you everybody, and have a great day. Be safe. Bye-bye.